Welcome to Digital Toolbox. Today we're going to recreate Louis Kahn's cycloid volt arc by using a list of numbers, and then these numbers will become a list of points, and then we'll create a curve which will be our arc from these points. We'll also learn how to rotate objects or curves, and to keep in mind while we're creating this definition that the cycloid volt is derived from one circle with a fixed point at the bottom of the circle, and as the circle rolls from left to right, the path of the point creates the arc. So start a new definition, and I'm going to curve and grab a circle since that's what the arc depends on. Go back to parameters and grab a number slider. I'm going to edit this slider to be integers and the value to be 50. I'm going to rename it span in feet. And to convert circumference into radius, I'm going to go to logic, go to script, and grab a one variable equation. I'm going to edit this in the expression editor. X over 2 times pi, which is derived from the circumference formula. So now we have the circle is based on the span, or the radius is based on the span. So now we need to put these circles across the x-axis, which is a 50-foot span, on a list of points. So to do that, we'll go to vector and grab in point x, y, z. By default, x, y, and z is 0. So we can connect this to the p. So now we need a list of numbers in x, so we have a list of points. So to do that, we're going to go to logic, go to sets, and grab the series button. Here, if you hover over the right side of the S, it goes from 0 to 9 with an increment of 1. So the S controls the initial value, N controls the increments, and C controls the number of values. So I'm going to copy this slider. I'm going to change this to number of points. And I'm going to edit it to become 25. So to get 25 points, we need increments in between. To do that, I'm going to take the span divided by number of points with a two variable equation. So x over y. So now we have an increment of 2 feet. I'll plug that into the increment in the series. So now we need the number of points. Since we have 25, we're going to put that in, and if you can hover over the right side of the S, you can see it goes from 0 to 48. Since 0 is the first number, it counts that as 1, and then 2 is the second number, since Grasshopper is base 0. So you need to add one more point to 25. We can do that in scalar by going to operators and going to addition. And then I'm going to set the number for B, which is going to be 1. And then replug that into C. Now you can see if you hover over S, it goes from 0 to 50 at an increments of 2. And then plug those list of numbers into X. So now we have 26 points across the span and 26 circles respective to the points that we plugged in. I'm going to reorganize this. So now we need to rotate each circle by a specific angle. So I'm going to go to X form, go to Euclidean, go to rotate. G means the geometry that we want to rotate, which is our circles. And then P means the base point, which will be our points. Each circle has their own point. And then A means the angle in radians. To figure out the angle of each rotation per circle, we have to analyze our increments. That each circle has traveled 2 feet. That means it traveled 2 feet on its circumference, which is in reality the arc length. So therefore, taking the radius and the arc length, we can find the angle by taking the arc length divided by the radius. So I'm just copy this two variable equation. I'm going to put the arc length into X and then Y into the radius. And now if you hover over R, the angle of change is 0.251. So that's the increment size we want per circle to change. So I'm going to go back and copy the series and paste it. So this will be our new increment. So now if you hover over S, it goes from 0 to 6.28, which is 2 pi, and 2 pi is 360 degrees. So that's what we want, so we're going to put that into A for the angle. Now to see how, if it's actually rotating, we need a fixed point. So we're going to go to curve, go to analysis, and evaluate the length. In the evaluate and random tutorial, it goes over this button. So I assume that you guys understand this button. So we need a point that is at the bottom of the circle, of the first circle. So that's 0.75. So I'm going to go to number in primitive and parameters. I'm going to edit this to become 0.75. I'm going to rename this as 0.75. Now plug this into L. So now it starts from the bottom of the circle, and it seems to be traveling in a counterclockwise direction, since that's the travel of the unit circle, the direction of the unit circle. So to do that, we're going to switch the angle to a negative. So now it's traveling in the clockwise direction. So now we have our points to form the arc. I'm going to unpreview these things that we don't need to see. So to create a curve from these points, we're going to go to curve, go to spline, go to interpolate curve, and connect the points to V. V means the points to create the curves. D is a degree of curvature. Anything less than 3 will create a more rigid curve. And P is, if it's true, that means it'll close the curve. That means it'll swing back to the first point. And if it's false, it'll leave it open. This is what we want. So from here, you guys are done. But what I like to do is create something so I can bake it in Rhino easier. So I'm gonna grab a receiver, and I'm gonna put C to the receiver and the receiver to the curve. So I can drag this back to the left side of my work plane. So every time I need to bake this geometry, I don't have to drag it to the right side. Also, we should know the height of the arc. So to do that, we're going to go to logic, grab a one variable equation, and plug the radius into x. And we're going to format this expression so it prints out into a post-it what its height is. So type in format, and then open parentheses, open quotations, and anything in the quotations will be printed as text into your post-it. And then a comma after the quotation can be your expression. So we need to double the radius, so that will be our height. I'm going to grab another receiver, and I'm going to put it to R, and then I'm going to put the post-it to the receiver. So now it reads out height in feet at 15.95. I'm going to grab this and swing it back to the left side of my screen here. Now why do we use receivers? Is so to get rid of unnecessary obstructions when we look at our work plane. Such as the wires, we don't want it swinging back and creating more of a mess. So that's how you create the Louis Kahn cycloid volt arc, and thanks for watching.